In this example, we will learn how to find the coefficient of static and kinetic friction. See you inside. A steel block with a mass of 5 kg rests on a horizontal plane, and a force of 12 Newton is required to set, you should know that term, set, to set the block in motion, and a horizontal force of 9 Newton is needed to keep, even this one, to keep it in motion. Calculate the coefficient of static friction and the coefficient of kinetic friction. Alright, so as I have noted the two phrases set and keep. Set is for static and keep is for kinetic. Hello everyone, I'd like to show you how to calculate the coefficient, or how to find the coefficient of static and kinetic friction in this example. Remember, mu is equal to F mu over NR. That's just the normal formula for mu. But now we need to find mu s, which will then equal to our F set divided by mg, because our nr is mg. So we divide by mg, we just do the quick substitution. You can just substitute. Our fr is 12, our mg is 5 times 9,8. Then you can take out your calculator and press that thing. 12 divided by 5 times 9,8. The answer is 0,22. 0,24489. So this decimal we can, because we need to take only 3 decimals, but now after the third decimal we have 8. 8 is above 5, so that means we can make this second 4 to be 5. So we'll have 5 there. And also we know that mu has no units, so we'll leave our answer just like that. Then we move to the second one where we need mu k. So mu for kinetic friction will definitely equal to F keep divided by mg or nr. So our F to keep is 9. So we have 9 Newton divided by 5 times 9,8, which will equal, now there the top we will have 9. So let me get my 9. Then we'll have 0,1836. Again, 6 is more than 5, so that means this 6 can round up and make this 3 to be 4. So it'll have 0,184, and still you do not have units, so that will be your answer. That's how you will go about to solve such a problem. An object is pulled upwards against a slope of 20 degrees with the horizontal. A force of 300 Newton parallel to the incline is required to pull the object with a mass of 50 kg up an incline. Calculate the coefficient of friction between the surfaces in contact. Alright, as you can see, I was doing this, but I noticed that my camera is not working, so I will restart it so that I can, because there is a lot of explanation I was doing, so I can't just leave that behind. We have our data. We are given that theta is 20 degrees, ft is equal to 300, m is 50 kg, and whatsoever. So we should always remember that g is equal to 9.8 meters per second squared. Now we should ask ourselves a question: what is the formula for mu? Remember, mu is equal to f mu divided by nr, as you saw from the problems that from the explanations we were doing previously. Then we do not have f mu, we do not have nr, so that means we will have to make means to find both f mu and nr. What is the formula for f mu? The formula for f mu, okay, this is just the skeleton of what we are doing. So the formula for f mu, we have our f mu equaling ft minus mg sine theta. That is our f mu. What about nr? Remember, which is fc. So nr equals fc basically. So we have f mu, we have nr. So this basically. So let's start to answer now our question. Our ft is equal to 300. Our fs is equal to mg. M is equal to 50 to be 132,410. We can skip the 0 since it's the third decimal, because after 0 it's 1 and 1 cannot work here. So we'll skip that 0. Then we know that this is measured in Newton because it's a force, so we'll have newtons as the unit of measurement. Then now we need nr. So the answer is 400. Now after the 9 it's 3, so that means there is no change, because after 9 we have 3, so that means there is no change. We'll keep it as it is. So that's what we will end up with. It is measured in newtons. Then we can come to our Then let's come back to our calculator. So that's your equal sign. You can see that is 0.28. When you put it here, is 0.2875. Now that 5, you can keep it like that as 7.5 or just make it 8. That is the answer for our mu. So we managed to find mu both for these ones and for these ones.